So just to kind of refresh our memory on what some of the terminologies are, is that we've been dealing with what we call here is the radical sign. Okay, so that's the radical sign. Okay, up here we've had a number. Okay, I'm just going to do a hashtag, signifies a number. That number is what we call the index. Okay, if you don't see a number there, it's an implied 2. Right? So if it's like square root right here, there's nothing there, that's an implied 2. If it has a 3, that's a cubed root. 4 is the 4th root. 5 is the 5th root, etc. And that index tells us how many you need of that number to pull it out to the left. Okay? And then in here, in this number here, I'll just make it x, that right there is the radicand. Okay, so just kind of some terminologies to refresh our memory. Okay, so we're just going to go down here to the bottom, or to this middle part here, and just kind of remember how to simplify. So looking at the radical sign, you take the number inside and you want to break it down to the smallest possible units as you can, the factors of it. So 24 we could take down and break it down into what? 8 and 3? Okay, we'll do 8 and 3. Doesn't matter if you did 12 and 2. Doesn't matter if you did 6 and 4. 8 and 3. Doesn't matter where you start from, because when you get down to the very end you'll have the exact same numbers. Okay? 8 then can be broken down to 4 and 2, and then 4 can be broken down to 2 and 2. Okay? At this point we look to the index to see how many do we need of a kind to pull it out. Okay? Well, it's 2, so I'm looking for pairs of numbers. Okay? So I see I have 2 2's here. Okay? So I get to pull out a book of 2. So I'll pull that out, and then I'm left with a 2 and a 3. Right? Those aren't pairs, so those stay there. Okay? So underneath the radical sign remains the 3 times the 2. Okay? So then we multiply those, and we just get to the square root of 6, and then that becomes our answer. Okay? So then we look at the exact same example, but now this has an index of 3. So we do the same process. Okay, we could do 8 and 3. The 8 becomes 4 and 2. The 4 becomes 2 and 2. But now my index is 3, so I need 3 of a kind before I can pull anything out, right? So I'm going to look for 3 of the same number. So I have 3 2's here. Okay, so that's 1 book of 2 I can move out to the left. So I pull that out to the left. I still have my radical sign here. I'm left with a 3 that's by itself, so that remains underneath the radical sign. Okay? And then that becomes my answer. 2 squared roots of 3. Oh, actually cubed roots of 3. Don't forget to keep your index the same. Okay? Alright, so let's look at 54. So now here we have 54 and we have x to the 5th. So here we have a variable with it. So we deal with the numbers on themselves, and then we look to the variable second. So we could take 54, and 54 can get broken down into, I'll say 27 and 2. 27 can get broken down into 9 and 3. And then 9 can be 3 and 3. Okay? How many of a kind am I looking for? 3, because my index is 3, so I'm looking for 3 of the same number. So I'm going to go in and I say, okay, there's 3 3's here. So I can pull that 3 out. Okay? And I have my radical sign here. Alright, so now I'm going to look to the variable. So 2 ways you could do this. You could take the x and break it down into 5 x's. And then you could go, these would all be x's. And then I could say I need 3 x's to pull 1 out, so I could do this. I could go, oh, there's 3 x's right there. That's 1 x I can pull out. Okay? And then I'm left with how many x's underneath? 2, right? Well, there's also another way you could do it. You could take the 5 and divide it by 3. So I take this 5 and divide it by 3. And when I take 5 and divide it by 3, how many times does 3 go into 5? 1. And then what's my remainder? 2. So this is what gets pulled out, and this is what stays in. Okay? So I have 1 x that comes out, and I'm going to have x squared that stays in. Okay. And looking at the numbers, we're still left with this 2 right here by itself, so that remains inside. Does that make sense? Okay. All right, one more, and then you guys are going to try a couple on your own. All right, I'm going to actually write over here just because I feel like I'm running out of space. All right, so I have 72x cubed. I'm going to break 72 down into, let's do 36 and 2. Okay. At this point, I can go 6 and 6, and I can go 3 and 2, and I can go 3 and 2. I can stop actually at 36. Yeah, I'm just going to walk through it, and I'll tell you guys some shortcuts. Okay. So here, what am I looking for? Pairs of what? Pairs of 2s. So I need 2 of a kind. So, because my index is an implied 2. So let's see, I have a 3 and a 3, so that's 1 3 I can pull out. I have a 2 and a 2, so that's 1 2 I can pull out. Everything you pull out, you multiply together. Okay? I am left with a 2 here, so I'll do my radical sign of 2. And then I have my x cubed. Well, I'll take 3 and I'll divide it by 2. 3 divided by the index. I get 1 with a remainder of 1. So that means 1x gets pulled out, and that means 1x remains in. And so that can reduce down to 6x square root of 2x. Okay? Alright, something to kind of notice as well. If I did 36 and 2, if you realize this is all underneath the radical signs, by the way, so this is really like the square root of 36 times the square root of 2. That's really what you're saying right there. What's the square root of 36? It is 6. At this point, if you know that that's 6, then you can stop right there and just pull out your 6. See how eventually you get to 6? So I could just stop right here, and this could become 6, and I would have 6 square roots of 2. So if you see it from this point, you can stop right there. If you don't, work your way down to the smallest factors, and then multiply them together. Okay? Does that make sense? Okay. Alright, so we have a couple here I want you guys to try. Let's do this. Let's try the first 3. We don't need to do the last one. Let's just try the first 3, okay? So, very quickly, I'm just going to go through this. So, if I look at 16, okay, 16 is really 4 and 4, which is then 2, 2, 2, and 2. Again, if you see that, the square root of 16 you know is 4, you can just stop and pull it out. You don't have to go all the way down to the bottom here. If you don't see it, you'll get to it because 2, you got 2, the index is 2, so you need pairs, 2 pairs. So I pull out a 2 and I pull out a 2. So that'd be 2 times 2. Well, what's 2 times 2? 4. Okay, so if you see right here, 16, you know the square root of 16 is 4. Just pull it out. Okay? Then I have x to the 8th. My index is 2, so I take 8 and I divide it by 2. And so I get 4. It's an even. There's no remainder, so I'm going to pull out 4 x's. Okay? And then I have a 7. I take 7 and I divide it by 2. I get 3, and I have a remainder of 1. So I can pull out 3 y's, and I have a remainder of 1, which means underneath the radical sign, I have a y. Okay? If you don't see it, you could take all these and just break it down. 1, 2, 3, 4, 5, 6, 7, and you'd have y, 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 y. You're looking for pairs of 2, so it'd be 1, 2, 3 pairs of y's, right? That becomes a y cubed, and I have 1 y left over. Okay? Alright, so for this one here, we're looking for the 4th root. Okay, so we need 4 of a kind now. So I'd have 4 and 4, and that'd be 2 and 2. So now I need 4 of a kind. Well, there's 1 4 of a kind, and that gets pulled out just to be a 2. Then I look at my variable. I have 5 divided by 4. Well, 4 goes into 5 one time with a remainder of 1, so it's going to be x here. And then underneath my radical sign, I have x. And then I have y to the 4th divided by 4 is just 1, so I just have y pulled out. Okay? Remember to put the index on the corner. I always forget. Okay? Alright, 16 is the cube, so we're going to do, we have 4 and 4, and then we'd have 2 and 2. And then we want 3 of a kind now, so I'm going to take the three 2's, and that becomes a 2. I'm left with underneath the radical sign of 2. There's nothing else that goes with that. I take my y to the 4th. 4 divided by 3 is 1, so I know I get 1 that gets pulled out. I have a remainder of 1, so that remains in. And then make sure you carry the index on top. Questions on that? Okay, so that should be a refresher. So basically we're going to learn a couple new things that are going to be like a step above this, and then we'll continue on with this. Okay? So what we have here is we're going to be talking about multiplying and simplifying. When you have radical signs where this little square, you guys see this on your page, that's actually a multiplication sign. So when you see it, it's just really multiplying. Okay? So it's just saying that the square root of 3 times the square root of 12. Okay? You can rewrite, whenever you have two radical signs like this, you can just really rewrite them as the square root of 3 times 12. You can put the values all underneath one radical sign. Once you do that, you can then multiply what's underneath there. So I would then have it as the square root of 36. Okay? So all I did is take the square root of 3 times the square root of 12. I made one big radical sign. I put the two radicands together and multiplied them. 3 times 12 is 36. And then you just simplify it. So now you would go to what we just did, the process. So do we know what the square root of 36 is? It's just 6. So your answer is 6. So if I would actually put this in a calculator and I would multiply the square root of 3, get that answer, and then multiply what the square root of 12 is, and I put it together, I'd actually have the answer of 6. So your value should not change. Okay? Alright, so let's look at this next example. We have the cube root. Now, before you do this, the one thing you have to make sure is you must have the same index to multiply. Okay? So if this was the square root of 3 times the cubed root of 12, you cannot do that. Okay, my indexes are not the same.
So it just like doesn't work.
Your answer is just the square root of 3 times the cube root of 12. Okay, unless you can break down the cube root of 12 more, but you can't. Okay, your indexes, this and this, must be the same for you guys to be able to multiply them. Okay, so I'm going to look at this example here. And I have it the cube root of 40n squared times the cube root of 2n cubed. Okay? My indexes are the same. I have a cube root, so I can multiply them together. So I just rewrite it, cube root, and then I'm going to do 40n squared multiplied by 2n cubed. Okay?
So you can still multiply like that, like different exponents for n squared and n cubed?
Yes. You can.
As long as the index is the same.
Correct. You can multiply the exponents underneath here if they're different. You just can't do it unless they both have the same index. Okay? So then I would just do what I normally do when I'm multiplying. These are monomials now, so I have two monomials being multiplied together, right? So I take the 40 and the 2 and I'd multiply them. Okay, so I'm going to get the cube root of 80. And then I take my two variables, n squared times n cubed. What's the rule for exponents when you're multiplying? You add. So I'm going to have n to the 5th. Okay? Am I done? No, you are not done. If this was your final answer, you'd probably lose a point on a test. Okay? We need to then now simplify it. Okay? So now I have the cube root of 80 n to the 5th. Alright, so I'm looking for a cube root. So 80 can be like, what, 42, 4 and 10, 2 and 2, and then 5 and 2. Okay, so I'm looking for 3. I need to have 3 of a kind. So I have, let's see, 1, 2, 3 2's there. Alright, so I can pull 1, 2 out. I'm left with a 5 and a 2 underneath. Can I do anything with those? No. Just multiply them together so they just become 10 underneath. Okay. Then I look to my exponents. I have n to the 5th. I take 5 divided by 3. How many times does 3 go into 5? 1 time. How many do I have left over? I have 2, so I have n squared. Okay? And then that would be your final answer. Yes?
Will there be any case where you can't do it like this, like you can't break it down?
Possibly. It may be your final answer. I doubt it, but possibly. Okay? Alright, so let's look at any question on that. Alright, let's try this one right here. We have cube root of 3. I'm just going to rewrite it just because it's times the cube root of -9. So I'm going to rewrite this as cube root of 3 times -9. Okay, they have the same index, so that's good. So now I'm going to do cube root of -27. So then -27 can be broken down to 9 and 3, and 3 and 3. I'm looking for 3 of a kind. I have it right there. I pull it out. What do I need my 3 to be, though? Positive or negative? It needs to be negative because it's a -27. Make sense? Alright, so let's look at this one down here. It's kind of a long one, it looks like. We have cube root of 54x squared y cubed times cube root of 5x cubed y to the 4th. Can we multiply those together? We can't because the index is the same. So I'm going to rewrite this as the cube root of, I'll do 54x squared y cubed times 5x cubed y to the 4th. Okay? 54 times 5. Do we know what that is? What's that? 270. I have x squared times x cubed. How many x's is that?
5.
X to the 5th. I have y cubed times y to the 4th. How many y's are that?
7.
Okay, and that's all underneath the cube root.
9.
Okay? Alright, so now we need to break this down. We need the cube root. So, 270 can be broken down. We can take that into, what, 27 and 10? And then 27 eventually becomes 3, 3, and 3. Okay? It's kind of messy. You guys see how I did that? So it's 9 and 3, and then 3 and 3. So I'm doing a cube root, so I pull out 1, 3. And then what am I left with underneath the radical sign? 10. So I look x to the 5th. I had taken the cube root, so how many x's can I pull out? 1. And then how many x's am I have left over? 2. I have y to the 7th. How many y's can I pull out? 2. And I'm left with 1 left over. Make sense? Okay. Alright, let's flip. Alright, so that was multiplication. Now we're going to do addition. Addition is, again, the only way that you can add these together is if they have the same index, okay? And they have the same radicand. So this is a little bit different on adding. So to add, okay, you must have the same index and the same radicand. To multiply, the radicand didn't matter, but the index did, okay? It's like if I have 2x squared and I add 3x squared, what's my answer? If I take 2x squared and add 3x squared, what's my answer? 5x squared. Okay? The only thing that changes is the coefficients, right? My variables stay exactly the same, correct? So notice how I didn't change that, right? If I did 2x squared plus x, what's my answer? 2x squared plus x, right? I can't add these two together because they don't equal, they're not the same term. You see that? This is the same thing for when you are adding radicals. The index and the radicand have to be the same. It's kind of like that's an x or x squared. You can't combine different ones, okay? Alright, these are the same. I have the same index and I have the same radicand, right? Square root of 3, square root of 3. So I can just add them, just like I would do for 2x squared plus 3x squared. I just add them. So that becomes 6 square roots of 3. My radicand does not change, only the coefficients change. So you add just like you normally would. Add or subtract, same thing. You can do the same thing with subtracting, okay? So if I look at 5 square roots of 5 plus 2 square roots of 10, can I add them together the way that they are? No, I cannot. Am I done, do you think? No, what do you think I can do? I could probably take the 2 square roots of 10 and try to get it to be a square root of 5, and then I could probably add them together. Okay? So let's see, can I take the 2 square roots of 10 to make it a square root of 5? Well, I have 5 and 2. Can I make a 5, this 5 times 2, is there any way I can pull a pair out? No, I cannot add these two together. So therefore, you just don't do anything. This is your final answer. So your final answer, this one is 5 square roots of 5 plus 2 square roots of 10. That's it. Okay? Okay. So now, let's look at some examples. So we have 5 cube roots of x minus 3 cube roots of x. Are the index and the radicand the same? They are, so I can subtract them. So 5 minus 3 becomes what? 2. So I have 2 cube roots of x. So again, the only thing that changes is the coefficient. Okay? Alright, so now let's look at this. I have 5 square roots of 75 plus 2 square roots of 12. Does it appear that I can merge those or add those together? It doesn't in the form that it's at. So what do I need to try and do? I need to simplify them both and see then if they're the same. So let's take 75. 75 can be 25 and 3. Okay? 25 is going to be 5 and 5. And then I have over here, I have 2 square roots of 12. I can make this, what, 4 and 3, and that becomes 2 and 2. So I can take the 5 square roots of 5. This becomes 5 times, okay, I have a 5 I can pull out here, square roots of 3. And then over here, I have a pair of 2's I can pull out, so I have 2 times 2, square roots of 3. Okay, so this 5 here and this 2 here are from what's already out there, and then I'm multiplying with what I pulled out. Okay, so this becomes 25 square roots of 3 plus 4 square roots of 3. So what does that equal? 29 square roots of 3. Okay. So it may not appear that you can add them, but then once you simplify them down, you see that their index and radicand are the same, so now you can actually put them together. Okay? Alright, see if you can't try this one here on your own. Try that one there. Okay, so on here, it doesn't appear that you can merge them together, so let's try and see if we can take the 3 square roots of 27 and break it down. 27 becomes 9 and 3 and 3 and 3. We can take out this set of 3 here. So it's, don't forget you have a 3 right there. It's going to be 3 times 3. Square roots of 3 left over. And that's plus your 2 square roots of 3. So it's 2 square roots of 3 plus 9 square roots of 3. And that becomes an 11 square roots of 3. Questions on that? Okay. So if I look at these 3 right here, okay, I have a square root of 50, a square root of 32, square root of 12. Over here I have a square root of 3, square root of 12, and a square root of 75. You would want to break each one of those down, okay? And then you would want to then add any of the ones that have the same radicands together, okay? When you have 3 of them like this, you have to work each one of them separately and see if you can add them together, okay? I want to go on to the next examples, and we can go back to this if we want, okay? But you want to break each one of these down individually and see which ones you can merge together. If you have ones that don't match, then those just become its own term. You can't merge them together. Yeah?
So, in the case of having the 3 different ones, or the 50, 30, 12,
Yep.
if you had 2 of them turn out the same and then have one that's different, would you add those 2?
Yes.
And then have you separate that one?
Yep. So if, let's say, 2 of these match, you'd add those 2 together, and then the one that does not match, you leave on its own. So it's kind of like up here where you had a 5 square roots of 5 plus 2 square roots of 10. Let's say I had a 3 square roots of 5. I would combine these 2 and not that one. And so my answer would be 8 square roots of 5 plus 2 square roots of 10. Yep. So you only combine what you can combine, and then the other ones are just, it's just like the 2x squared plus x. They just become separate terms. Like that. Okay? Alright, good. So now, we just talked about multiplying, and we talked about adding. So what we have is a kind of a combination of both. If you notice, we have an expression here that may look complicated, but it's really not. This really would be no different than if we saw it as, let's say, 3 plus 2x and then 2 plus 4x. Okay? If I saw this right here, what would I do? I would do the, I would do the distributive property, right? Each term on the left needs to get multiplied to each term on the right. So I would do the 3 times the 2, I do the 3 times the 4x, I do the 2x times the 2, and I do the 2x times the 4x, right? That kind of bring back memories of what we used to do? Okay? Well, we're going to do the same thing here. This is no different in regards to process, okay? So let's just start. So let's start with the 3 and multiply the 2. So what's 3 times 2? 6. Alright? We'll do 3 times 4 square roots of 5. Okay? So I would deal with this just like I would do with any multiplication. I'm going to take the coefficients and multiply them. So what do I get there? I get 12. And then I just have a square root of 5. Okay? Just like if I had the 3 times the 4x, what does that become? It becomes 12x, right? So this is going to become 12 square roots of 5. Alright, then I'm going to do the middle term here. I'll do the 2 square roots of 5 and I'm going to multiply it by the 2. So what do I get here? I have 2 times the 2, which is 4. 4 square roots of 5. Okay? Just like I have the 2x times the 2 here, which would become 4x.
Where did you get the 12?
I did the 3 times the 4 square roots of 5.
Or do you just multiply 3 by everything?
Yep. So I take the 3 and multiply by the 2. I take the 3 and multiply by the 4 square roots of 5. I'm going to take the 2 square roots of 5 and multiply by the 2. And then I'm going to take the 2 and multiply it, the 2 square roots of 5 and multiply by the 4 square roots of 5. Okay? So if you recall, when we have these two, when you're multiplying with the same index, right, what do you do with the inside? You just multiply it. So this actually becomes 8, and I would have the square root of, and if you want to see it, as 5 times 5. Okay? And that's really what I'm doing, the square root of 5 times the square root of 5. Okay? So then, what is 5 times 5? 25. So I have the square root of 25. What's the square root of 25? 5, right? So this then becomes 5. So this becomes 8. It's going down each to simplify it. 8 times 5. Okay? So then, if I want to simplify everything, I have 6 plus, okay, now I'm going to add my middle terms here, because I have a 12 square roots of 5 plus a 4 square roots of 5. Remember, the addition is as long as the radicand and the index are the same, you just add the coefficients. Yes?
Why would it not be 15 for, like, the 6 plus 12 square root of 5?
I can't combine the 6 with the 12 square roots of 5 or the 4 square roots of 5 because it does not have a square root of 5. I can only combine like terms. This square root of 5 and this square root of 5. Okay?
You're not combining them when you multiply it out.
when I multiply the 3 to the 4 square roots of 5,
Yeah.
I only multiply the coefficients. This is the 3 times the 4.
So you just leave whatever else.
Yeah, just like over here, see where it's 2x times 2, right? 2x times 2, or 3 times 4x, either one. I take the 3 and I multiply by the 4x to get 12x, right? So this is the same concept. The 3 times the 4 square roots of 5 is just going to be 12 square roots of 5. The square root of 5 is kind of like a variable. Did I not answer that question?
No, yeah, so you,
Okay. So then I'm going to combine my 12 square roots of 5 plus my 4 square roots of 5. So that's going to become 16 square roots of 5. Because when you add, remember, you don't change the radicand, okay? And then I'm going to have this, which is the 8 times 5, which is plus 40, okay? So now I can combine my like terms, so my 6 and my 40 become 46. And I get plus 16 square roots of 5. Yes? Okay. Now, what I want to show you guys is a little hint here. If you notice that this 2 square roots of 5 times the 4 square root of 5 end up just being the coefficients multiplied times the value that was inside. So this will always be, if I take these, the square root of anything multiplied by itself becomes what? Just itself, right? So I can just take the value that's inside and multiply it by the outside. So if you don't see that, then you would follow the principles of multiplication where you say 5 times 5, that becomes the square root of 25, and then you would break it down. Or you could just see the value that's inside and know that's going to be what you multiply your coefficients by. Does that make sense what I just said? Okay. So let's look at this next example here. So I have negative 2 times 6. So we have 2 terms here multiplied by 2 terms, so I have to do the distributive property. So I'll take the negative 2 and multiply it by the 6. So negative 2 times 6 is what? Negative 12. Right? Then I'll take negative 2 and multiply it by a negative 2 square roots of 5. So what does that become? A positive 4 square root of 5. Okay? Then I'm going to take the 2 square roots of 5 and I'm going to multiply it by the 6 here. Okay? So I have 2 square roots of 5 times 6. That becomes a positive 12 square roots of 5. Then I take the 2 square roots of 5 and multiply by negative 2 square roots of 5. Okay, so the 2 times the negative 4 becomes what? That's a minus 4, and then what am I multiplying it by? Square root of 5 times square root of 5 is actually what then? It's going to be the square root of 25. What's the square root of 25? 5. Okay, so I just need to take the value of the square roots actually drop out and become that value there. Because square root of 5 times square root of 5 equals square root of 25, which is then just 5, and that's how I got that number there. Okay? So then this right here becomes a negative 20, because I have negative 4 times 5, so that becomes negative 20. Okay? And then if I go and I add all these together, okay, I'm going to combine my like terms. Well, these are the same radicand and index, so I can add these together, so these become 16 square roots of 5, right? And then I have a negative 12 and a negative 20, and what does that equal? Negative 32. So negative 32 plus 16 square roots of 5. And then you guys get to work on your homework. Notice how I have this example right here. It says 7 minus 6 square roots of 8, and it says it's what? Squared? Alright, so what this is actually saying is it's saying that this is happening twice. So 7 minus 6 square roots of 8 multiplied by 7 minus 6 square roots of 8. Alright, so when you see this, that's what it's saying. Is whatever that exponent is telling you how many times that whole term is getting multiplied. Okay? So you would want to rewrite it like that. So now that I've rewritten it like that, what do I need to do? Go through the distributed property, right? Alright, go ahead and give it a shot. Okay, just real quickly, you guys, it looks like a lot of you guys got it. So 7 times 7 is 49. Then I have a 7 times a negative 6 square root of 8. That's going to be minus 42 square root of 8. Then I go the middle term, or the last term here, to the first term. So that's going to be negative 6 times 7 square root of 8, so it's minus 42 square root of 8 again. And then I have a negative 6 square root of 8 times a negative 6 square root of 8. So negative 6 times negative 6 is plus 36. And then I'm going to multiply that by, it's like the square root of 8 times the square root of 8, which is like the square root of 64, which is 8. So just times 8. So this will always be, the square root signs will drop, and it will always be the value inside. Okay, if they're the same. Okay, does that make sense? So then I'm going to add them together. So I have 49, 36. What's 36 times 8? What'd you get? 36 times 8? 228? 288? 288. And then 49. And then this is going to be minus 84 square root of 8. So I have, 288 and 49 becomes 337 minus 84 square root of 8. Questions on that? Okay, we have learned, kind of refresh our memory on what we were doing on simplifying. But then we learned about multiplying and how if you have, as long as you have the same index, you can multiply what's inside, and then you can simplify. Okay. Then we had where if you add or subtract, you need the index and the radicand to be the same, and then you just add or subtract the coefficients. Okay. If they don't match, you want to break it down, and then see which ones you can combine. And then we looked at multiplying polynomials together, and what we're finding is the distributive property, and then you multiply them through and then combine the like terms. Okay? So that was kind of today.